Stanford University.
Variety of announcements. Tomorrow office hours are shifted because at 4:30 there's a really interesting lecture over at Clark. This guy is one of the experts on the whole notion that there are brain metabolic abnormalities in sociopathic humans, violent criminals. He's got the distinction of having the world's only portable MRI. He has a big old Winnebago with an MRI machine, and he drives all around the country from one maximum security prison to another, trying to look at aspects of frontal cortical dysfunction in extremely violent individuals. I have no idea if he's a good lecturer or not. The material is going to be really interesting. So that's something that probably should be caught. Friday, again, is not going to be videotape, but just audio tape for a number of reasons. Finally, over next year, I will be doing, if anyone is interested, some directed readings with people that will be essentially more of an exploration of some of the topics in the course here. So if you are interested, do not send me anything whatsoever until it's the summer. At that point, CV, transcript, anything I need to know, but it'll be posted on the courseworks as to more details about it. Okay, so we pick up with the home stretch here of language. And what we got to just on the edge of 2 days ago is to now begin to look at the genetics of language use. In general, there's the usual types of techniques from behavior genetics. The first is looking for covariance of certain language abnormalities in certain families. And the evidence for that is clear with Williams syndrome, with the selective language impairment. Those tend to run in families, and they tend to show classical Mendelian inheritance, very readily thought of as genetically influenced disorders. Then going to our usual deal of looking at adopted individuals, twins, identical twins separated at birth, that whole armamentarium of behavioral genetic stuff. What does that show? There's a fair degree of heritability of things like vocabulary complexity, ability to spell, skill at phonology, things of that sort. In general, the evidence is pretty poor for a strong genetic load on dyslexias, on learning disorders of that type. Of course, the modern version of it all is to start looking at the actual genes, the molecular biology of language disorders, of language in general. First thing that comes up is this gene that has been at the center of the whole field for years now, a gene called FOXP2. And it was originally identified as having a mutation in a family that had a very specific linguistic problem running through it, language generation, speech. This family had severe problems with it, classic looking for a genetic marker, and eventually narrowing down to a gene itself, turning out to be this mysterious gene, FOXP2, which turned out to be a transcription factor and a mutation in it in this family. What immediately became clear is this theme over and over again with language, insofar as there's a problem in this family. Is it at the cognitive level of what language is about symbolically, or is it just getting your lips and tongues and articulating and that much more mechanical level? It initially looked like it was much more the latter in this family. It is apparently more of a mixture of both, just to make things really confusing. What you see is it is preferentially expressed in that part of the brain we heard about the other day, the basal ganglia. That area that's playing a role in gesturing when you're speaking, playing a role in facial prosody, that sort of stuff, motoric stuff. And the fact that it was found so heavily expressed in there, it was part of what got people to think what's fundamentally wrong with this family is motor aspects of language production. Again, it's gotten messier since then, because these folks have a variety of cognitive impairments in the realm of language. So of course, immediately what we need to be asking is, what's FOXP2 doing in other species? Does it occur in other species? And it turns out that it is all over the place. You find FOXP2 in birds and mammals and all sorts of things, large and small. It is very, very widespread. But, importantly, a different version than you find in humans. It is immensely conserved, which is to say you see the same version of FOXP2 ranging from apes to birds, everything in between. Nothing has changed with that evolutionarily in a long, long time. So what does it do? Handful of studies in animals where the gene has been knocked out, it has been removed, where you now have mice that do not have the gene. And what you see is there's less vocalization and simpler vocalization. And that's back to our whole world of that sonic vocalizations that you can't hear when mice are giggling and that sort of thing. Knock out this gene and there's less vocalizing and there's less complexity to it. So it's doing something or other that looks plausible. And it's expressed in motoric parts of the brain preferentially in these other species. So the super conserved version of this gene, everybody else has the same version, and then you look at the human version and there's a bunch of differences, and they emerged very recently. Best estimates are the last couple of 100,000 years. Each one of the changes extremely positively selected for. Whatever this gene is about, once it sort of went on the human path, it changed real fast under major selective advantageous conditions, and thus we've got a real different version from everyone else. Next interesting thing about it, insofar as it is a transcription factor, when you look at the genes that it regulates, so this is now taking our one step further, our old genetic network deal. When you look downstream, what genes it regulates, they tend to be fairly differentiated from other primates and to have differentiated as a result of positive selection. So this is a whole cluster of genes that evolution was doing some pretty stringent things on in hominids in the last couple of 100,000 years. Now, what you do is one of the all-time cool studies, which was last year, which you take mice and you knock out their FOXP2 gene, and now you stick in the human version. And amazingly, what happens is, once these animals mature, they speak just like Mickey Mouse. Okay, people were listening. What you wind up seeing is it's probably the Disney people probably are working on it, and that's going to be the end of life as we know it when they let those ones loose. What you get when you when you express the human FOXP2 in a mouse is a mouse with more vocalizations and more complex ones. Whoa, that is mighty interesting area of lots and lots of work these days trying to figure out what this transcription factor is about, but clearly just this screaming imprint of major league selection that has gone on for the human version and for the genes that it regulates. Fairly recently, it is no surprise that this gene is central to such a different, unique thing that we're doing. More evidence for genetic components to language. And this one is a very indirect one, but this totally interesting phenomenon that has been shown in lots and lots of different places on the globe. So you get some circumstance where a whole bunch of people are brought together from different cultures with different language groups and wind up having to deal with each other. Classic version is you get, for example, slave populations brought from different places in West Africa to some of the Caribbean islands. You have on some of the Hawaiian islands, early in the last century, people from all over Asia brought over to work the plantations there, the fields, whatever. What you have in these cases is a whole bunch of people thrown together who have languages from every which way who don't understand each other. And what always emerges, what has been extremely well documented, is some sort of fragmentary communication system that is made up of bits and pieces of all the relevant languages, which everybody can kind of limp through and begin to be understood with each other. And what that is wound up being called is a pidgin language. Pidgin, very simplistic version that shows virtually nothing in the way of complex grammar, and it's basically a vehicle for getting individuals, who almost always in these cases are societally pretty under the foot of powers that be, to deal with each other, to work with each other, working out this proto-communication system with fragments of each language. Okay, that's not surprising. What is totally cool is what happens next over the next 1 to 2 generations, which is this pidgin thing, this committee glued together amalgamation of fragments of different languages within a generation or two has evolved into a real language, which is then known as a Creole language. Creole languages are languages that are a couple of generations descended from pidgin, and what you see is it winds up being a real language. That's fine. That's, fine, given that 2 days ago we're hearing that it was possible for kids to come up and invent Nicaraguan Sign Language within a generation. Okay, so you start with this pidgin thing, and within a couple of generations it turns into a real language, fits the rules, grammar, all of that. Here is the thing that is so interesting about this phenomenon, which is all of the Creoles have the same grammatical structure. What is that about? Creoles from all over the planet that were built upon all sorts of differing hodgepodges of original languages in the pidgin. Creole languages all have a similar grammatical structure. Easy explanation, easy boring one, which is it's very simple grammatical structures, and this is a language that's just getting off its feet in each case. No. In all these cases, it is grammatical structures that are not necessarily the simplest. It's not just some baby step languages, it's languages that all seem to come up with the same grammatical structures there, and what this has given rise to is the notion that there is a default grammar built into humans. Let humans go running with a whole bunch of fragments in different languages, and not surprisingly, we're able to turn it into a real communicative system within a generation or two. And when pulling language out of thin air, humans always tend to come up with the same sort of grammatical structures that are not necessarily the simplest. Argument there being there is an innate, there is a hardwired, there is an ancient default pattern of grammar that humans use when they come up with language. So totally interesting. What do you find also with the sign languages as they get invented? Nicaraguan Sign Language, it went through a first generation of being pidgin and soon turned into a signing equivalent of Creole, and it has some of the same grammatical structures. Even when humans are defaulting into a new language that's purely gestural, it shows some of these constraints that you see with the Creole languages. Other features of this that come through. Apparently, there's like 24 different ways that you could put together objects and subjects and rejects and participles and whatever it is, grammatical structures. This guy, Joseph Greenberg, linguist, who was here at Stanford until a few years ago when he died, apparently an incredible titan in the field, he did some of this research. There's 24 possible different ways languages can do this object-subject business, and all across Earth, all across the 6,000 languages there, you only see 15 of them used. And the vast majority of grammars on Earth only use 4 of them. So the argument there winds up being, this is a pretty non-random skew. Again, we're seeing some kind of prepared learning default grammars, this very imprecise sense of there's something genetic floating around here. So that complementary to the whole world, instead of looking at things like FOXP2 and its mutations, the usual two very different approaches. That whole Pidgin to Creole transition is really, really interesting, and it really has this feel in the undercurrents of it that there is a basic human grammar that floats around there, a notion that Chomsky has pushed for a long, long time. Okay, jumping one box further back, ecological factors and language. And we'll touch on that only briefly, but what you've got is something similar to a theme we heard a couple of weeks ago, which is possibly not something we heard a couple of weeks ago, and we'll instead hear on Friday. But what you see is diverse ecosystems, very biodiverse ecosystems. Rainforest ones, for example, produce cultures which have a great deal of diversity in them. What we're going to see on Friday, the version of that, which I'm now thinking I did mention before, is that polytheistic cultures are the things you tend to see coming out of rainforest settings. That notion that if there's 100, if there's 1,000 different types of edible plants in your world, it doesn't take a great leap to decide there's a whole lot of different spirit things in the world going on there, polytheism. A very similar theme, great work done a few years ago, a guy named William Sutherland from the University of Dundee, I think, where what he showed was looking all over the planet, looking at the biodiversity in different regions on the planet. The more ecological diversity, the more linguistic diversity you would find in that region. The more different languages, which of course thus translates down into small groups, small numbers of speakers, this interesting phenomenon, which it's not completely clear to me what to make of that, but ecosystems that are very diverse generate an abundance of theistic notions at above expected rates, and also produces a whole lot more languages, something in the diversity there. What his work then showed is about everything else I'm going to say in this area, which is just totally depressing stuff, which is linguistic diversity is going down the tubes faster than biodiversity. He shows that the rate of language extinction proportionately is faster than the rate of extinction of various species, plants, etc. in these rainforest ecosystems. Totally grim, depressing picture. What seems to be the case, given where things are heading, is in the next century, in this century, 90% of Earth's languages will go extinct. The vast majority of humans on this planet speak less than 10 different languages out of the 6,000 existing ones. How's this for depressing? There's a couple of hundred different languages that are Inuit and Northwest Native American and some other population as well. And currently, only 5% of those languages have speakers who are not elderly. That's real depressing also, and something that strikes me as extraordinary is in each one of those cases, somewhere along the way, there's going to be somebody in old age who's the last person on earth who understands their language. There's not a single other person alive who will be able to talk in their mother tongue with them. Languages disappearing left and right, along with, of course, cultural diversity going down the tubes, the process of turning the whole world into a lowest common denominator of McDonald's culture, blah, blah. Along with that comes a huge, huge loss of language diversity. Finally, jumping to our last box, if we're talking about ecological factors, thinking about things like genes, thinking about things like highly, highly driven positive selection for genes like FOXP2 in humans, of course, we have to talk about the evolutionary end of things. So, evolution of language in humans. General notion is click languages, which you tend to see in hunter-gatherers in Africa, that might have been the earliest forms, the most ancient types of languages on Earth. And what you also see is hunter-gatherers are probably the most ancient sort of populations of humans that live in Africa, with waves of agriculturalists coming from North Africa, the Middle East at later points, pastoralists coming from around there as well. The original populations in Africa were hunter-gatherers, and they have high frequencies of these click languages. That might be the starting point for human language. Interestingly, though, you also see click languages among a lot of Aboriginal groups in Australia. What does that tell you? Those came separately. There was a huge gulf of time between leaving Africa and the first populations winding up in Australia. Convergent evolution. For some reason, click languages is a very fundamental way that people come up with communication systems. So, selection issues, often running with our sociobiological notions of language advantages. It's easy to see what the advantages are of having a language system. It is easier to store, to archive knowledge, information. It is easier to coordinate hunts. It is easier to figure out what we did the last time there was a famine. Figuring out things like that, all of those facilitated by language. In the memorable words of Steve Pinker from Harvard, language is how we outsmart plants. Language allows us to do all sorts of organizational stuff. Language evolution is all about sequence. We don't say words simultaneously. It's all sequences, and a number of people have emphasized that's what the construction of tools are about also. A whole process of careful, logical, sequential transitions of steps, almost certainly tool use and language use as sequential processes emerging in parallel. Finally, obviously, you see all sorts of room for cooperation with kin selection, cooperation with reciprocal altruism being enhanced with communication, but very importantly for our game theory world, what language also allows you to do is lie. That whole business from 2 days ago, in human language, there's that arbitrariness. There's a dissociation between the message and the messenger. It's not like dogs that have to put the lid on their fear pheromones by tucking their tail. What you have is the capacity to lie. And of course, running off from that, a whole world of evolutionary strategizing. Pertinent to that, there's a huge disproportionate share of neurons in the motor system devoted to facial expressions and mouth coordination and all that kind of world. A really good thing if you plan to lie is to be able to have good control over your facial expressions. Finally, formal game theory models showing when you have pairs of individuals playing against each other, when you allow the emergence of communication between two of the players versus not in the other group, you immediately, no surprise, have them getting a big advantage. If you allow them semanticity, to have words that they can communicate, that is advantageous, that improves outcome. Even better is if you allow semanticity and structure, syntax, grammar, so that they can have more complex communication. All of those wind up being things that facilitate winning in game theory settings. Finally, interesting parallelism back to that biodiversity stuff, which is when you look at all those different possible grammatical structures, the 24 of them, 15 of which is the total of what appears on Earth, the rarest of the grammatical structures are the ones that are closest to extinction. The rarest, not in terms of the number of people speaking it within a population, but the structures that have occurred the fewest number of times in cultures across the planet are the ones that are in cultures where the languages are most readily to be lost, some sort of connection there. And thus you've got some sort of weird grammatical imperialism that has emerged over the years. Again, what strikes me as like a totally depressing number, 90% of Earth's languages will disappear in the next century. Okay, so now we jump to our next topic, which is our first psychiatric disease. And to remind you from 2 days ago, we're not going to have a depression lecture. The depression chapter in the Zebras book will tell all the same stuff in much better, more clear terms, I say, proving my point. And what you should do is read it with as much attention to it as if it has been a lecture subject. It is an important subject. Enough hints. Okay, so check that one out. What we focus on today, though, is schizophrenia. And we're going to take our same old strategy, starting off with what does the disease look like, and as you will see, all sorts of surprises in there, and then what goes on in the brain just before, early development, prenatal, genes, evolution, the whole deal there. We know this drill once again. So starting off, making sense of schizophrenia as a bunch of behaviors, you got to challenge right off the bat, which is lots of people use the word schizophrenic in an everyday sense that has no resemblance whatsoever to its actual technical use. Schizophrenic or schizy, and we all know that one. We thought, my God, I am having such a schizy day. I overslept. I missed my first class. It was terrible. I totally screwed up. But then I found out I got this great grade on a midterm, but then I had this fight with a friend, but then in the afternoon, and then this crashed, and blah, blah. God, what a schizoid day I'm having. No resemblance to how the term's actually used. That's not any sort of real term in psychiatry, whatever the schizy days are that we all experience now and then. Schizophrenia is something else. On the most technical level, schizophrenia is a disease of people where when you start talking to them, within 2 or 3 sentences, you realize there's something strange with their thinking. They're not thinking normally. They're not communicating normally. On the most fundamental level, that's what the disease is. Okay, obviously far more precise than that. Schizophrenia, disease of thought disorder, disease of inappropriate emotion, disease of inappropriate attribution of things, and what you'll see is this is not just some sort of generic craziness in the way that that word means nothing whatsoever. There are typical structures to the ways in which things are not working right in the behavior of schizophrenics, which we'll hear about in a bit. Part of what begins to bring that across is the obvious fact that there's no way that schizophrenia is just one disease, because there's all sorts of subtypes. It is a bunch of heterogeneous diseases. You have a subtype paranoid schizophrenia, where what it's all about is thought disorder built around a sense of persecution. You have catatonic schizophrenia, where the person is in a frozen state, immobile for long periods of time. You have schizoaffective disorders, which is kind of a mixture of schizophrenia and depression disorders. It's not just one disease. So the whole sort of array of behavioral symptoms we're going to look at now, remember, some of them are more common in different subtypes than others. This is just the first broad overpass. So beginning to make sense of the disease. What it is, above all else, is a disease of cognitive abnormalities, of abnormal sequential thought. And the term that's given for it is loose associations. All of us can tell a story where we have a pretty good ability to put it sequentially and have the facts go in a way where it will make sense to any other listener. You do not see this in schizophrenics. Sequential thinking is greatly impaired. And instead of having logical sequences of information that they give, things tangent all over the place, bouncing around all over, where in retrospect you can kind of see how they might have gotten from A to Z, although most people would have gone from A to B at that point. The tangential thinking being another term for it, the loose associations. So what do you wind up seeing there? You get schizophrenics, for example, who get terribly confused in a sentence, whether when they are hearing about boxers, they are unable to keep straight within one sentence to separate out whether they're talking about a dog or they're talking about an occupation, because they slip back and forth between the two. Confusion between being a caddy, someone who golf, whatever, and a Cadillac, short term for that. All sorts of ways in which they can't hold on to the sequential logic, and instead there's just this tangenting, getting caught up in the loose associations. You're talking about a boxer. If you're schizophrenic, you're talking about a particular boxer, you follow that sport, whatever, and suddenly you're expressing an opinion about how that person would do in a ring against a St. Bernard. And you're often talking about dogs from there, just getting caught by a loose association between the sound of the word and its multiple meanings, going off the tracks on that. So the loose associations. Next, you have a consistent one with abstraction. All of us have a pretty good intuitive sense when someone is telling us a story. Is this meant to be literal reporting of events in a sequential way? Is this meant to be a parable? Is this meant to be a somewhat second-hand through the grapevine story? We have a very good sense of how concrete or how abstract the information that we're getting is. Schizophrenics are terrible at that. They have no intuition to get the right level of abstraction. And schizophrenics always skew in the same direction, which is to interpret things far more concretely than is actually the case. And that's the term that's used in the business, concreteness of thought, which is having a lot of trouble doing the more abstract process of seeing things on a metaphorical level, things of that sort. So here's a standard sort of test you would give to someone if you think they're schizophrenic. You give them an association task. And you say something like, okay, can you tell me what do these things have in common? An apple, an orange, and a banana. And they'll say, all of them are multisyllabic words. You'll say, okay, well that's great, that's true, but anything else they have in common? Yep, all of them have letters that involved closed loops. Just getting caught up in the most concrete possible level of interpretations of it, not able to step back and do any sort of abstracting. You see this in all sorts of other ways. Therapist will meet the patient and say something like, so what's on your mind today? And they'll say, my hair, in this very literal sort of way. Or you'll say, can I take your picture, holding a camera? And they'll say, I don't have a picture to give you. This very literal sense again. Or things like, you would sit down as schizophrenic with a piece of paper and a pen and say, just as part of what we're doing here, can you write a sentence for me? Any sentence. And then you look at what they've written, which is a sentence for me, any sentence. And then you say, no, actually that's not what I mean. I mean, can you come up with a sentence, and when you've thought of that sentence, write it. And they'll write the word it, because they can't get out of the concreteness of saying, could you write a sentence? Can you write, a sentence? They're caught up in the concrete level of that. A way that always pops up, one of the classic types of tests that's done is called proverb tests. Proverbs, by definition, they are metaphorical, they are parables, they are abstract, and we all know intuitively that when you're talking about birds of a feather flock together, you're doing something sort of symbolic about the well-known homogamy of lips with and people and who they choose to marry and the similarities. Yes, birds of a feather flock together, it's talking about like tend to assort with like. Give proverbs to schizophrenics and they can't get out of the most concrete level of interpretation of it. So you sit them down and you say, okay, tell me what this means. A rolling stone gathers no moss. And we all know that people are on the move, don't make emotional connections, there's a detachment, whatever. And they're often saying, stones rolling down hills, it's very hard for plants to grow on them. It's very hard because the surface tends to be smooth, and then on top of it, if it's rolling, you got like this angular motion that will trip. So it's very hard for moss to grow on stones. In fact, I don't think I've ever seen that happen, and I've seen many stones, and on the most concrete possible level, incapable of pulling it back to the level of abstraction. Consistent feature of this. Here, a friend of mine who's a psychiatrist came up with what has to be one of the all-time great proverb tests for figuring out if someone has the remotest tendency towards schizophrenic concreteness. There was an abstract phrase, sort of proverb, that was very popular, that was very prevalent in the United States during World War II. It was up on posters in all the post offices, places like that, and it was a way of abstractly telling people, be careful the information you put in letters that you were sending off to loved ones who were off at war, because it may inadvertently wind up in the wrong hands and could carry information that could be extremely damaging to the war effort. Okay, do people know what it is? Loose lips sink ships. Loose lips sink ships, wonderfully abstract notion. Try sitting down a schizophrenic and saying, what does it mean when you say loose lips sink ships. And suddenly there's this imagery of ships being capsized by big lips coming out of the water and things of that sort, because it can only be dealt with on the very concrete level. What else? More symptomatology. Delusions, belief in things that cannot be, belief in having participated in historical events that cannot be. You're sitting there interviewing a schizophrenic and they suddenly say, have you heard of the Great Wall of China? And you will say, well, yes, in fact I have. And they'll say, my idea, my idea. The generals came to me at night with a map and I said, this is where it goes. This is probably not what happened. Delusional thought, inserting yourself conversations with people who no longer exist. Related to that is the paranoia, which of course is most florid in paranoid schizophrenia, but it is a frequent theme. What do apples, oranges, and bananas have in common? They're all wired for sound. If the fruit is listening to you, this makes for a rather disquieting life. And almost certainly it has something to do with, if the world is making so little sense to you, it is a world that is very threatening. Along with that, most famously perhaps with schizophrenia, is you get hallucinations. Those are the defining features. Somebody is trying to figure out if somebody in an emergency room has come in with some sort of schizophrenic type disorder and hear that the person is hearing voices, and that pretty much nails down the diagnosis. For reasons that are very poorly understood, the vast majority of hallucinations are auditory. However, there's all sorts of notions with that. One great theory coming from our own Patrick House, given 2 years ago, which is you get auditory hallucinations more often than visual ones because we're more accustomed to visual stuff in the world, having fragmented vision. You're seeing it across two mirrors, reflections, things of that sort. We are more vulnerable towards sounds not making sense. Vast majority of hallucinations in schizophrenia are auditory hallucinations. When we see in a little while what the neurochemistry is of hallucinations, by all logic what they should be is just random splatters of noise and random visual dots and all of that. Instead, they're structured. They have content. People hear voices rather than random sound. People see very structured hallucinations, sufficiently so that researchers can even do studies as to which are the most common voices heard by schizophrenics. And no surprise, in Western cultures forever and ever, the number one voice on the hit parade is that of Jesus. The number two voice, Satan. The number three, typically whoever is the head of state in the country at that point. It's structured to that extent that you can publish papers about what the hallucinations are like. There's all sorts of structure sort of underneath. It is not just disordered thought, it's loose associations and tangenting and concreteness and structured hallucinations. What else? Another feature of the schizophrenic symptoms is social withdrawal. And schizophrenia, everybody thinks of as a disease of abnormal thought. It is a disease of abnormal social affiliation. And you look at a schizophrenic in, some village in who knows where in the Amazon or in Bloomington, Indiana, and this is going to be someone who is somewhat ostracized and socially disconnected, very much alone. It is not just a disease of disordered thought. More and more people are realizing the core with schizophrenia is the disordered thought. The standard view has always been to hone in on the most florid feature of the disease. Schizophrenia is the disease where you hallucinate, where you hear voices. And the vast majority of the neuropharmacology research that's been done out there on the disease is meant to go and cure the hallucinations. But far less responsive to any of the drugs are the tangenting thought, the concreteness, the loose associations, more and more people thinking that that's really the core of what the disease is about. Couple more features of it, which is the whole world of the social withdrawal. Apathy. What we're beginning to see is a dichotomy in the business. Positive symptoms in schizophrenia, paranoia, loose thoughts, hallucination, all of that. Negative symptoms of schizophrenia, the absence of social connectedness, the absence of affect, a very flat, unexpressive style. Physiologically, you see some damping of autonomic nervous system in schizophrenics, so the positive and the negative symptoms of the disease. Last couple of features of it. One is the notion that, of course, schizophrenia has something to do with violence. Everybody knows that there is the scenario lurking out there that occurs endless number of times, which is you have some psychiatrically unstable individual turning out to have schizophrenia who winds up doing something horribly violent, the danger of schizophrenics cracking and going postal, and every now and then something like that happens. 20 years ago, there was a horrifying incident at Berkeley, a student there who was schizophrenic and probably should not have been there at the point because he was not well medicated. Something cracked and he took a bunch of Berkeley students, women, hostage in a bar in Berkeley, did all sorts of horrific sexually abusive things there before he killed himself after killing a few of them. This is what happens when something like that occurs with a schizophrenic. Oh my God, so we've got all these people running around where that could be happening any second. Schizophrenics are far less dangerous than are normal individuals in society. The rates of violence are extremely low, with one exception, which is schizophrenics being violent in damaging themselves, self-injury. A huge feature of schizophrenia, part of the delusions, part of the thought disorder, part of the despair, when every now and then your head clears enough to see what the rest of it is like. And there are even studies as to which are the most popular places in the body that are mutilated in schizophrenics. Genitals are top on the list, and going down from there. Horrific thing that happened also about 20 years ago, Columbia Medical School. And this was an individual, a student there, with a history of a lot of psychiatric instability and schizophrenia, and somewhat well controlled with meds. And somewhere in the third year, when starting the clinical rotations, the various stressors of it, the person kind of unraveled. Probably should not have been there in the first place, but nonetheless had a schizophrenic break and had withdrawn from med school and was sitting at home. Part of his paranoia, part of his delusions were that he was satanically possessed, and specifically the way Satan was driving him to madness was with obsessive sexual thoughts. So being a relatively well-trained endocrinologist, because we know better than him at this point how it works, he decides, how do I make those thoughts go away? Let me get rid of my testosterone. So he castrated himself. But at least being well-trained in one domain of endocrinology, he knew that other fact we've had in here, which is that the adrenal glands also make a certain degree of testosterone. And he proceeded to try to adrenalectomize himself. He sterilized with some alcohol. He made an incision without anesthetic. He had a mirror there angled to be able to see what he was doing. And at one point, he hit a blood vessel, which started bleeding, and he went to the ER at Columbia Presbyterian, going in there, not saying to his former classmates, oh my God, guys, can you help me? Look what I've done. I'm saying instead, hi guys, I'm trying to take out my adrenals and I'm having a problem here with it. Can you give me a hand? This is very disordered thought. This is a very elegant version of it. Schizophrenic self-injury, schizophrenic suicide is anything but clean. Number one on the list, genitals. Number two for women, female schizophrenics, breasts. Number three, thighs. On it goes. This brings up another feature of the disease, which is back in the 1960s, when all sorts of laudable things happened along certain cultural lines, there amid that was one horrifically damaging, idiotic thing that emerged in psychiatry at the time, which was a sort of minority view in psychiatry, a lunatic fringe view that basically schizophrenia is not so bad. Schizophrenia has all sorts of hidden blessings. And soon it had frameworks of things like schizophrenia is the disease of being healthy in a crazy world. Schizophrenia is the disease of having insights into life that other people can't. And psychiatrists at the time, one of them, a man named Ronald Lang, who became famous for this, for arguing it's not a disease, we shouldn't be medicating, we shouldn't be hospitalizing, it's a bunch of blessings. And it is even continued to this day. The quote that I put on the top of the handout, Andrew Weil, who's one of the gurus of sort of complementary medicine, and as you'll see, an absolutely ridiculous statement there along the lines of the hidden blessings of schizophrenia. There were movies at that time. King of Hearts was one very popular one about somebody having to hide from the police or who knows what in the asylum, and eventually releasing the schizophrenics who were so much saner than the other people around, and heartwarming. And all you need to do is be schizophrenic or know someone who is, or have a family member, and you will see there are no hidden blessings. This is not a disease of hidden compensations and more insight into the world. This is one of the most horrific ways that biology can go wrong, and one of the best demonstrations of it is half of schizophrenics attempt suicide. And the more often you have periods of remission, the more likely you are to commit suicide. What's the significance of that? The more often you have periods where you're clear-headed enough to see what your life is like the rest of the time, the more likely you are to try to kill yourself. A disease with no hidden blessings whatsoever. Other features of it. There's an aging component, two different forms. First one is, as schizophrenics become older, elderly, what you see is the positive symptoms tend to disappear. The hallucinations get damped, the delusions, the loose associations, and the negative symptomatology is what comes to the forefront, this world of just flat affect and withdrawal. The other age feature of it, we will hear about in a bit, which is real defining, which is schizophrenia is a disease where in the vast majority of the sufferers, it has late adolescence, early adulthood onset. It is a disease of 18-year-olds who come down with the diagnosis for the first time. If you make it to age 30 without schizophrenia, you have virtually no chance of ever having it. It is a disease of adolescent onset. And this is going to fit with two things we'll be talking about. One is the epidemiological evidence showing that what schizophrenic breaks typically are at the very beginning are in response to major stressors. These are individuals who have always been a little bit odd, who in elementary school had imaginary playmates far later than most other kids did, who had all sorts of periods where they seemed not to be paying attention and lost in their own thoughts, who had trouble making friends, but they were okay. They were sort of hanging on. And then it was late in high school when they had the car accident, or the first boyfriend was so horrible to them, or the parent died, or whatever the crisis was, and this person who was just sort of holding on, that's where the dip occurs. That's where it crashes. Schizophrenia as an adolescent onset disease where stress plays a major precipitating role. The other piece that we'll see is the fact that schizophrenia almost certainly is heavily anchored in the frontal cortex. Frontal cortex, you remember the frontal cortex, which was not fully mature until age 25 or so. The last big burst of frontal maturation, late adolescence, early adulthood. We'll see there's lots of reasons to think that schizophrenia is a disease where around late adolescence, a fragile, vulnerable frontal cortex gets kicked once too hard with something or other, and that's where the problems emerge. Couple of other features. Demography in every culture ever looked at on Earth, 1% to 2% of the population comes down with it. No gender differences, no socioeconomic status differences in terms of who becomes schizophrenic, but once you are, there is the not very surprising downward socioeconomic spiral, which is, no surprise, people who are schizophrenic do not make very good CEOs of large corporations. These are the street people. These are the homeless. The majority of people living on streets in this country are individuals who are schizophrenic. not alcoholic. That is the far more common thing that you see. So a disease of complete collapse into some of the least cared for sort of strata of society, that is part of the demographics as well. So that's what the disease looks like. And if you're really thinking about these symptoms, at this point, you should be jumping out of your chair because of something really disturbing about this collection of symptoms. Okay, so what is schizophrenia? It's a disease of thinking abnormally. This is a disease of thinking differently from everyone else. This is a disease of thinking in a way that everyone else thinks isn't right, and suddenly we are skating on thin ice of this transitioning from a world of neuropsychiatric disorders and medicine into a world of all sorts of hidden agendas of abuse. And psychiatry has been hand in hand in bed with all sorts of ideologues over the decades, over the years, in willing to hand out diagnoses of schizophrenia to political dissidents, to people you want to get rid of, and this is a totally loaded diagnosis when, most fundamentally, this is a disease of everybody else thinks you're not thinking normally. Because some of the time that describes a florid psychiatric disease that destroys your life, and some of the time it describes people who are just a pain in the ass, and some of the time it describes people who are going to transform the world by thinking differently. How can you possibly approach this disease in an objective way rather than it having just shot through with ideology? And one of the ways in which this can happen, one of the ways where you get some grounding in it, is to look at what the disease appears like in other cultures. Because you begin to see the commonalities, and this begins to impress you with the notion that there is, in fact, a core set of dysfunctions to the disease. So let me tell you about the one case of cross-cultural schizophrenia I've ever been exposed to. And I was going to bring slides, but I couldn't quite figure out how to scan them. So maybe 8 years from now, I'll get it together for that technology. But it has to do with the time I spent in Africa and my nearest neighbors. The nearest neighbors there are from a tribe called the Maasai. These are nomadic pastoralists, and these are not the folks next door. This is as different of a culture as you could find on this planet. Men around puberty, boys around puberty, become warriors, spend the next 10 years in their warrior clans, as we've heard about, pillaging the neighbors, getting killed in return around age 25. As elders, they settle down and marry their first wife, typically a 13-year-old, and will, as soon as they can, add on more. This is a culture with, up until recently, a life expectancy in the 30s. This is a culture where people believe in all sorts of things that we would view as being paranormal. This is a culture in which people celebrate events by drinking tureens of cow blood. This is a very different bunch of folks. Let me tell you about the one schizophrenic Maasai who I've ever seen. And this was about 25 years ago, and I was in my camp, which was a few miles away from this one village where I knew a lot of folks, and just sitting there minding my own business. And I had this one woman in there who was sort of my closest friend or whatever in the village, and I suddenly see she is running up the mountain with a bunch of the other women from the village in this completely agitated state. They come roaring into my camp, totally flummoxed and just like completely agitated. These are people who do not get agitated over things very readily. These are people who, as a puberty rite, have to go out and kill a lion or don't come back. So when Maasai are getting all crazed about something, this is something worth paying attention to. They're totally crazed, and they're saying somebody in the village has done something very wrong and I need to come and help them. Turns out what they wanted me to do was bring my car. That's the way in which I was going to be helpful. So they impressed me into doing this, and we all pile into the car and start driving down and heading towards the village. And as we're getting there, I'm beginning to get some information. And what I see is them telling me about a woman in the village who's done something wildly inappropriate, and they've had it with her. Now, I had been around that area for about 4 years at that point, knew most of the people in that village, and this was someone who I had never encountered. Aha, socially isolated, living in the back of some hut at the far corner of the village, a first sort of hint. Okay, so they're describing to me that she has done something inappropriate. She has killed a goat. You don't do that. You don't do that if you are a woman. You don't do that if it is not a ceremony. You don't do it the way she has done it. She has grabbed somebody's goat and ripped its throat open with her teeth and was now there with the goat, and everybody had it with her. So we're driving there and I'm listening to this and I'm saying, whoa, and this sounds like a psychotic break. This is going to be cool. This is going to be really interesting. I wonder what it'll be like to talk to the family and find out sort of what the symptoms have been. Or I wonder if she's going to have any insight. It's going to be fascinating to talk to her about this. So I get into the village, and this person I was now planning to have some good heart-to-hearts with about their tangential thinking, out comes this huge naked woman with a goat in her mouth by the throat, covered in goat blood and goat urine and goat shit, and this woman gives this howling yell, charges across the village, knocks me over and attempts to strangle me. I'm a normal kind of guy. You know, normal sort of fantasy life, and that kind of, never once in the darkest recesses of my mind did this strike me as something that was appealing. I'm lying there, she's throttling me, I'm thinking, this is how I'm going to wind up dying? My poor parents are going to have to deal with the stigma of this for the rest of their lives, that this is he's done in by someone with a goat in her mouth, and thinking this. So fortunately everybody else was much more clear-headed, and they pull her off me, and what they proceed to do is push her into my Jeep. And they pile on top of her and they say, let's go. So I collect myself and leap in, and we head off driving there. And this woman was floridly out of control there. But, you know, we're driving somewhere. Where are we driving? We're driving to the nearest government clinic, which was about 25 miles away and consisted of a wood shack and a nurse there, a government nurse, who as a result of his 3 weeks of training gave out malarial medication for anything you came to complain about. And what they were going to do was they wanted to get rid of her. So we go driving, and we eventually get to this clinic where what they proceed to do is push her into the hut and hammer the door closed. So I'm sitting there at this point saying, okay, well, we've containment. So what do we do now? Do we talk to her, or does the nurse talk to? Do we go and get the family? What do you? So I turn to my friends and I say, so what do we do now? And they say, let's get the hell out of here. Showing an important thing. Even in a culture as different from ours, nobody has a whole lot of tolerance for the mentally ill. Let's get out of here. So they persuade me to go. We get into the vehicle and start the long drive back. After a while, you know, the car's aired out a bit and everybody's calming down a bit, and I decide this was wonderful. What a marvelous opportunity to learn about some cross-cultural psychiatry or whatever. So I turn to my friend who's sitting next to me there, and I say, so what do you think was wrong with that woman? And she looks at me as if I'm an idiot. She says, she's crazy. And I said, well, how do you know? How do you know? And she said, she hears voices. I say, you guys hear voices. Maasai hear voices. They do trance dancing before they do sort of these around-the-clock cattle runs. They hear voices of ghosts, that sort of thing. I say to her, what's the big deal? You hear voices? And she says, no, it's different. Then I say, well, what else was she doing wrong? And she says, she killed a goat. And I say, you guys kill goats, but again, this wasn't how it's done. There is an old, long-standing belief among Maasai men that it is very bad luck to have women observe you eating meat, so they get to go off on their own and eat all the goat meat, and it's done in a certain ritualized way. You do not kill a goat if you are a woman, if you are a naked, yelling banshee of a woman in the middle of the village with your bare hands and teeth. You don't do this. So I'm sitting there and I'm saying, well, you know, it's kind of hard for me to tell the difference here. And she says, in a sense, idiot, she hears voices at the wrong time. And that's the core, ultimately, of the objectivity that's needed in this disease. In order to understand what counts as abnormal thought, you first have the huge challenge of understanding all the different ways that normal thought can manifest itself. And that is a classic problem in training psychiatrists sitting in some inner city clinic, recognizing that the amount of cultural variety there, the different ways in which you can be normal, is extraordinary and extraordinarily challenging at times. You are on very thin ice deciding you know what counts as abnormal thinking before you have a very wide sense of what can count as normal. Okay, so now let's take a 5-minute break, and all sorts of very accomplished artists over the years who've turned out to be schizophrenic, and schizophrenia is not what made their creativity possible. Schizophrenia is what destroyed their careers. Other question is, so what happened to that woman? And this was shortly before I was coming back to the States, and it was about 9 months later that I went back there, and at some point when seeing my friend saying, whatever happened to that woman? And her response was, oh, she died. Masai do not like to stay indoors, she died. That's all I ever found out. Once again, as different of a culture on Earth as you can imagine, and they are no more tolerant of the mentally ill than we are. So now, beginning the neurochemistry of it. What's going on in the brain? What's going on with brain chemistry? And for decades and decades, there has been one dominant model for schizophrenia, which is the dopamine hypothesis. The notion that somewhere in the brain, stay tuned, there is an excess of dopamine winding up in the synapses. What's the evidence for it? First off, you do things like look at levels of dopamine breakdown products in the bloodstream, in the urine and the cerebral spinal fluid, tending to be elevated in schizophrenics. Next, what you see is the most important fact, which is all of the classic drugs that work with schizophrenia block dopamine receptors. Antipsychotic drugs, neuroleptics, Haldol, Thorazine, when it's some exciting moment in the made-for-TV movie where the person has gone mad in the ER and someone yells for a syringe, they're yelling for a syringe of something that will block the dopamine receptors. If you give schizophrenics dopamine or some drug that activates dopamine receptors, their symptoms get worse, which kind of makes you wonder who approved that kind of study. That doesn't sound very logical. You look post-mortem at the brains of schizophrenics, and there's elevated levels of dopamine receptors in the frontal cortex. So we have a whole bunch of ways that things can go wrong. We can have too much dopamine coming out for some reason or other. We can have too many dopamine receptors, enhanced sensitivity. And we know another possible way, which is dopamine is then broken down by this enzyme. And if this enzyme isn't working very well, levels are going to accumulate. And there's a bit of evidence of abnormalities of this enzyme in some individuals. So one additional interesting piece of evidence for this dopamine hypothesis, which seems absolutely clear by now. You have somebody who's schizophrenic, you give them a drug that blocks dopamine receptors and thus decreases dopaminergic signaling, and they start getting better. What's your hypothesis have to be? I bet you they had too much dopamine. This is shown in another interesting way. 18 counties over in the brain from where dopamine's got something to do with this, dopamine serves another role in a motor system related to the basal ganglia, all of that, involved in fine motor control, a part of the brain called the substantia nigra. And if you get a little bit of damage there, I think I mentioned a couple of lectures ago, you get the tremor of old age. If you get a lot of damage there, you got yourself Parkinson's disease. And what occurs in Parkinson's is 90% of the neurons in the substantia nigra die. And people are even beginning to understand why. These are dopaminergic neurons. Parkinson's is a disease of losing all the dopamine signaling in this part of the brain. People began to figure this out in the early 60s, and out of that came one of the first drug treatments for any neurological disease. What's the strategy? These are people who have too little dopamine in this part of the brain. Give them replacement dopamine. Turns out it's hard to get dopamine in the brain, so you would give people one step earlier in the biosynthesis a drug called L-DOPA. L-DOPA, which then gets converted into dopamine, and this was miraculous. All sorts of people who were just paralyzed with their Parkinson's, L-DOPA suddenly liberated them. There was a movie, I don't know, 15 years ago or so, called Awakenings, Robin Williams, which was based on a book by Oliver Sacks, based on his own work, which had to do with this rare disease that emerged after World War I, having something to do with the influenza pandemic then, a post-encephalitic paralysis, which became known as stiff man syndrome. And people who are essentially frozen in place, and what we now know is it's an autoimmune disorder that targets something with the dopamine system. Sacks was a medical resident at the time, was at that point the L-DOPA stuff was just coming out with Parkinson's, and Sacks was the one who had the insight to say, I bet the stiff man syndrome is a case of the most extreme severe Parkinson's that you could possibly get, and thus he was the first one to try L-DOPA on people with the syndrome, and thus you had miraculous awakenings, people moving voluntarily for the first time in decades. Totally amazing. But then you have a downside, and it's a downside that we know sort of the structure of by now. You got a problem with dopamine in the substantia nigra, lower than normal levels. Everywhere else in the brain, you've got normal levels. So you're trying to fix up this depletion, you give the person L-DOPA, but you're not spritzing it into their substantia nigra, you're putting it in their stomach or their bloodstream. You are raising dopamine levels in the substantia nigra and things get better, but you're also raising it everywhere else in the brain. And what you wind up seeing is, if you give a Parkinsonian patient too much L-DOPA, they become psychotic. They are indistinguishable from a schizophrenic. And what was shown in the movie was this character played by Robert De Niro wound up having this florid paranoid psychosis from the L-DOPA. So, that being more evidence, you give a drug that raises dopamine levels throughout the brain and somebody starts acting schizophrenic. You give somebody a drug that causes very rapid dumping of dopamine, and they will transiently appear schizophrenic. What's the drug? That's what amphetamines do. And you get somebody come into an ER who is loose associations and hallucinating delusions and all of that, and most clinicians cannot tell whether this was somebody with an amphetamine psychosis or schizophrenia. Pump their stomach out. If they suddenly start making more sense, it was probably the amphetamines. So this being more evidence. Now you should be thinking, what about the flip side? So you have schizophrenics where you give them these neuroleptic drugs to block dopamine receptors in the frontal cortex, as it turns out, but you're not injecting it straight in there, you're putting it in their gut, so now you got too much dopamine here, you lower its levels, but everywhere else it gets lower than normal, not dopamine levels, but dopamine signaling. And suddenly, you should generate this prediction that if you over-medicate schizophrenics, they should start looking as if they have Parkinson's disease. And that's exactly what you see as well. A disorder called tardive dyskinesia, kinetics, body movement dyskinesia, abnormal one, and these are individuals who look Parkinsonian. Go into a state hospital, go into the back ward, and find somebody sitting there who is tremoring like this all over their body the entire time, and that's somebody who is going to have been taking these drugs for 20, 25 years or so. So collectively, this winds up telling you all these different ways of suggesting the problem is that there is too much dopamine in this disease. However, just to make life miserable, there is at least one anti-schizophrenic drug out there which what it does is it increases dopamine signaling and people get better. Bummer. Nobody knows what to make of this at this point. So what's the excess dopamine doing in there? It's not having anything to do with movement stuff, that's substantia nigra. It's not having anything to do with pleasure, that's dopamine in different parts of the brain. The best evidence is this is dopamine functioning in the frontal cortex, stimulating normal executive function. And what you got is a frontal cortex that is not making a whole lot of sense, loose associations that seems to be where the dopamine problem is played out. Next neurotransmitter that's been implicated, serotonin. look at the chemical structure of serotonin, and then look at the chemical structure of all of the major hallucinogens, LSD, mescaline, psilocybin. They are all structurally almost identical. And all of those hallucinogens fit into serotonin receptors and activate them. What is a hallucination induced by a drug? You've got some serotonin synapse where nothing's happening. The presynaptic neuron hasn't had anything interesting to say in weeks. It hasn't released any serotonin, but now there's something that kind of looks like serotonin percolating its way into the synapse where it could then bind to the serotonin receptors, and as far as this neuron thinks, it just got a message from there. And it didn't come from there. This neuron is hearing voices. And the fact that that's how the hallucinogens work immediately generated all sorts of hypotheses that there are abnormalities in serotonin and schizophrenia as well, having something to do with the hallucinations. Next, the neurotransmitter glutamate has also been implicated. What's the evidence there? When you take a drug that wildly stimulates one subtype of glutamate receptor, you begin to look a bit like a schizophrenic. What's the drug? PCP. Angel dust, phencyclidine, that stimulates a subtype of glutamate receptors, and a lot of people have argued this has enough resemblance to what schizophrenia looks like that there has to be a glutamate problem going on in the disease. Very, very little bits of evidence for that. The one thing that has been shown in rats is when you stimulate the brain with PCP, what you get is an increased levels of receptors for serotonin in some interesting parts of the brain, some kind of connection running around there. So very, very solid implication of dopamine, some serotonin thrown in there, glutamate, 11 other neurotransmitters that people are thinking about, but these are the main ones. And overwhelmingly, the dominant hypothesis remains the dopamine hypothesis. What about brain metabolism? What's going on in the brain, for example, during a hallucination? And what you essentially get is wild activation of everywhere in the brain, and you're hallucinating. You get wild activation. People who in imaging studies have taken these drugs voluntarily, you get wild activation in the cortex, except for, say, the first couple of layers of the visual cortex, or the first couple of layers of the auditory cortex. What's that about? The cortex is seeing things and hearing things that did not come in from the outside world, that never stimulated the primary sensory cortex. Otherwise, during hallucinations, you see extremely high levels of metabolism throughout the brain. Next interesting thing in that realm, you give schizophrenics some standard declarative memory tasks, and metabolism in the hippocampus does not increase as much as in other individuals. So that brings us to structural features of the disease. Yeah?
Does the brain, while hallucinating, does the brain look somewhat like when dreaming?
Okay, good question. Does the brain, in terms of patterns of activation, look somewhat like during dreaming? Yeah. It's not the primary sensory cortex regions that activate. Frontal cortex is relatively quiet, and the rest of the brain is going like mad. And certainly makes sense. So structural stuff. There's all sorts of structural abnormalities in the brains of schizophrenics. How do you learn this, though? Very difficult, because for the first couple of decades in the field, it was all post-mortem analysis, which is you take out the brain of a schizophrenic and you go and look at it and you see if there's anything weird. So what's the problems with that? All sorts of things, which is to try to do post-mortem studies on human brains. Different brains sit for different lengths of time before they're autopsied and removed. So that's a huge piece of variability. Moreover, you can get post-mortem artifacts, which is to say they're pulling out the brain and somebody like squeezes it too hard and squishes something in here, and it's not going to look normal afterward, reflecting the handling of it. And out of that has come this whole world of neuropsychiatry types where what they live for are rapid autopsies. And a whole bunch of medical centers have rapid autopsy teams connected with their Alzheimer's folks, connected with some of the psychiatric diseases, where their idea is to get in there as fast as possible with patients who have, or whose family have, given permission for that, and get the brain out as fast as you can. And I remember a few years ago I was down to Duke York Medical Center, and they have one of these rapid autopsy SWAT teams, and they were bragging about how they were getting brains out in under 30 minutes from death. So that solves a whole lot of the post-mortem rotting away lag time. So all of those wind up being problems. More confounds. Very often you're trying to understand the brains of schizophrenics who have died, who are older, who are elderly. And the confound there is schizophrenics have horrible diets. You are seeing perhaps the brain consequences of malnutrition all those years rather than seeing the consequences of the disease itself. Another problem that you've got is you get someone who's schizophrenic, and almost certainly what they have been doing for a long time is taking drugs for their schizophrenia. And if you see something different in the brain, maybe it's due to the schizophrenia, or maybe it's due to the effect of the drugs. And what that has generated is the other thing that people in this business kill for, which is unmedicated schizophrenics. And researchers love these people. They can't get enough of them. This is the teenager who is brought in and for the first diagnosis, and you know, the family is no doubt thinking, finally we're going to get some help. And all the researcher physician there is thinking is they want to centrifuge this kid and like do research and find that out, getting unmedicated schizophrenics. Finally, a big boon in the field has been brain imaging. So instead of trying to figure out the normal size of things after you've taken the brain out, you could image the brain in situ while the person is still alive. Okay, so given all of those methodological constraints, there's a number of things that have come up. Here's a cross-section of the brain, although I'm realizing this is a cross-section of a rat brain, and it also is a amusing face. And what you have are these things that run through the brain called the ventricles. They are these caverns running through, filled with cerebral spinal fluid. What you see in schizophrenia is enlargement of the ventricles. So the ventricles enlarge, the skull isn't going anywhere, and thus if the ventricles are getting bigger, something else has to be getting smaller. There is contraction, compression of the cortex. So you get cortical compression in schizophrenics. You get it particularly so in the frontal cortex. Aha, that's kind of interesting. Meanwhile, over in the hippocampus, what you have normally are these very characteristic cell fields where I just drew them wrong, neurons that are called pyramidal neurons that shockingly are pyramidally shaped. And what they have is they're organized in layers, and they send all of their projections off to the next cell layer that happens to be diamond shaped. And that's how it works. You look in the brains of schizophrenics post-mortem, and there's fewer hippocampal neurons, and there's some of them are facing the wrong way. They've been flipped over, they're sending projections where they're not supposed to. This is not going to make for a whole lot of solid sequential thought if you got neurons pointing in the wrong direction. So that's popped up in the literature. Then, of course, frontal cortex, where what's been seen is, in some studies, fewer neurons. In some studies, fewer glia. In some studies, fewer of both. What you see is also lower levels of a protein called reelin, and what reelin has to do is with cortical maturation. There's lower levels of it in the frontal cortex of schizophrenics. All of this begins to fit in this picture of you're not getting a normal final burst of frontal maturation, late adolescence, early adulthood. You're seeing a lot of problems there. What else? You also see a couple of other minor things. The thalamus tends to be atrophied. Nobody really knows what's going on. The sense is hippocampus pointing in the wrong direction, frontal cortex that's getting compressed because it's got fewer neurons perhaps. This is not going to make for a normal brain. So, now switching one box back, what about the genetics? And you'll notice this is one of our first topics where there's nothing been happening here in terms of endocrine effects, acute releasers, not terribly pertinent to this field. So what about genetics? Going back to all of our classic behavior genetics approaches, this has been the psychiatric disease where there was the first evidence for a genetic component to it. The twin studies, the Keddy adoption studies that we've heard all about, and what they have suggested was about 50% heritability for schizophrenia. And you're all over now what heritability means and what it doesn't mean. What you see within families is if you have an individual who has schizophrenia and they have an identical twin, the twin has a 50% chance of the disease. If they have a full sibling, about 25% chance of the disease. Half sibling, about 12%. Take a random person off the street, 1 to 2%. So there is a large genetic load. What you also see is in a higher than expected number of close relatives of schizophrenics are mild versions of thought disorder. And that's going to come in on Friday in a very interesting way. What this is saying right off the bat, it is not saying that all relatives of schizophrenics have these abnormalities, but they are occurring at a higher than expected rate. So that's old classical behavior genetics. Now, jumping forward a decade's worth of technology, how about molecular approaches, the version of just getting genetic markers? Not identifying the gene itself, but you remember this approach by now, where you were finding a stretch of DNA, and inside that stretch is a gene that is very pertinent to whatever it is, and the folks with the disease have a different version than the other folks, but you don't yet know what the gene is or where it is. So using this marker technique, some of the first disease gene markers came out in the mid-80s, late 80s for schizophrenia. And these were landmark studies, and everybody was incredibly excited about them, and these were really, really important, and there was a problem, which is somebody would isolate a marker for schizophrenia in an Amish population. People love studying the Amish for things like this because they've got big families, because they don't have a whole lot of substance abuse, because they have very healthy lifestyles, and most importantly, because Amish men who say they are the father of somebody or other are probably the father of the somebody or other. There's not a lot of messing around going on, and that's kind of helpful. You're trying to understand genetics, and if you don't even have the right person pegged as the father, that's going to make for some messy data. People love the Amish. People love inbred Icelandic fishing villages. These are all the folks who get studied, and in those years out came some of the first genetic markers. And the problem was each of the studies was getting a different marker, and nobody was coming up with any replication, a complete uninformative mess that was a major disappointment in the field. So very little happened in terms of the genetic marker approach. So we had to wait another decade or two, and now our current, more modern version, which is forget a genetic marker, what about actual genes? Are there genes that have been implicated in schizophrenia where there are abnormalities, where there are variances in it? It comes in 2 different flavors, 8 different flavors, our usual deal. We've already heard about one of these, which is variance in versions of this gene coding for this enzyme that degrades dopamine carries an association with schizophrenia. Nonetheless, very small effects. Interesting finding, and this was last year. These were 3 papers back to back in Science from 3 different groups, all of whom used a very contemporary technique for looking for genes, which is a SNP analysis, and it's really interesting, and not in a million years could I describe it clearly, but using this very state-of-the-art thing, they all had huge populations of schizophrenics, thousands of people in the study, great studies, and the amazing thing is they all found genetic abnormalities, and they all found one in common with a huge effect, which was very, very reassuring until you looked at the gene, which made no sense at all. All 3 of these groups, superb scientists, reported that in schizophrenia, you have a higher than expected rate of abnormalities in genes of the major histocompatibility complex? What is that about? The human equivalent? wait, we're back at pheromones and individual signatures and the immune system. What is this about? Nobody has a clue, but a remarkable consistency in these 3 studies. They all found abnormalities in these major histocompatibility genes that have to do with cell signatures and immune defenses, all of that, and these were big effects in all 3 studies. All the studies were done superbly. People are just beginning to digest that one. Nobody really has a very clear idea. Some other genes have popped up as having mutations or a lot of variants, where one particular variant is more associated with schizophrenia. And there's this one gene that's been found and replicated called DISC1. So what does DISC1 do? Nobody has a clue. And just showing how pathetic this whole finding is, what does DISC, D-I-S-C, stand for? Disrupted in Schizophrenia 1. That sure tells you a lot about what's going on. Well, what happens in schizophrenia? You have abnormalities in genes that are abnormal in schizophrenia. Let's party. So you got DISC1 and people trying to figure out it's got something to do with second messengers. Nobody really knows. There's not a whole lot that has been happening in this field that counts as progress. Really frustrating. People still need to make sense of this finding. One area, though, that's getting a lot of traction in the last few years goes back to one of our weird mutations from our macroevolution type lectures, that business of different numbers of copies of a gene. Macro mutations on that level, transposable events, gene duplications. A term we got back then is copy number variants. How many copies of particular genes? And the one thing that seems to be consistent is all sorts of genes in schizophrenia are popping up with abnormal numbers of copies of the gene rather than abnormalities in the gene itself. So that's really exciting. What's unexciting is nobody's replicating which the duplications are, and most of the genes, nobody has a clue what they do. People are flailing other than seeing there's all sorts of different genetic abnormalities that are popping up. How can that be? How could they all be relevant to this disease? Back 1 hour, it's not a disease. It's a whole bunch of heterogeneous ones, and there's going to be all sorts of different genetic components to it. Okay, now our next box. Early experience. And what early experience immediately translates into is parenting style. What does schizophrenia have to do with parenting style? We will see shortly, which is my smooth way of trying to say that I just jumped a paragraph by accident. So of course, where we begin is looking at the role of early stress in life, because that's obviously where you have to begin discussing early experience and schizophrenia. It's that whole stress model thing. We already heard one version of it. The adolescent stressor takes the kid who's just barely holding on and dips him way down. Another version of it that should seem plenty logical to us by now, prenatal stress. People who were fetuses during the Dutch hunger winter have a higher than expected rate of schizophrenia. People who were fetuses during a huge famine in China, 1959 to 1961, higher incidence of schizophrenia. Rats, expose them prenatally to lots of glucocorticoids, and they wind up having elevated dopamine levels in their frontal cortex. Have mechanical trauma at birth, birth trauma, brief hypoxia, any of those things, increased incidence of schizophrenia. This is very interesting. Back to our business, remember identical twins, they can either share one single placenta or have two of them, monochorionic or bichorionic. Monochorionic twins are more likely to share the trait of schizophrenia than bichorionic identical twins. Fetal environment stuff's going on there. What else with that? You wind up seeing a lot of suggestions of interactions between the neurochemistry of stress and some of the abnormalities here. You know how this works. Somewhere lurking out there is a data set that's going to wind up looking like this. Bad version of the gene, good version of the gene, more and more stressful of a developmental environment. It hasn't been identified yet, but it's got to be something like that because everything's like that. So, leading us now, obviously, to discussing parenting style and schizophrenia. So where does that come in? Take the best psychiatrists in the field, the titans, the grand poobahs in 1950, and they would know the exact answer, which is parenting style is the cause of schizophrenia. Abnormal parenting is the cause of schizophrenia. And out of this, of course, since in those days fathers did no parenting, what you were saying was abnormal mothering is the cause of schizophrenia. And the great term that was used there was schizophrenogenic mothering, mothering style that generates schizophrenia. What was schizophrenogenic mothering about? Well, it depends on whose paper you're reading. But in general, what they tended to have were elements of conflicting emotional messages. Conflicting, a double bind is the phrase that always ran through it. The mother gets their son 2 ties for his birthday. He puts one of them on. She says, "What's the matter? You don't like the other tie I got you?" Or at the more fundamental level, saying, "You never say you love me. You never say you love me. You never say, I love you. How can that mean anything to me when I just forced you to say that?" There's no winning. And in that view, what schizophrenia was about was raising a kid with distorted, contradictory, fragmented emotional demands from the schizophrenogenic mother, and out comes schizophrenia. Now, actually, by the early 50s, people in the field were feeling far more sort of broad in their thinking, recognizing this might be damaging, in fact, to women who were the mothers of schizophrenics, and a much more humane model came in, which was recognizing the possibility that fathers could screw kids up in the same way. What was more broadly called this double-bind theory of schizophrenia, it is caused by parenting. It is caused by particular parenting style. And then, in the early 50s, along came the very first drug for schizophrenia, the neuroleptics, the dopamine receptor blockers, and over the course of the next few years, 90% of the hospital beds in this country for psychiatric patients were emptied out, the first medication that effectively treated schizophrenia, and at that point, if one had any sort of capacity to face reality, all of the proponents of schizophrenogenic mothering should have been shocked and stopped in their feet at that point, saying, "My God, what have we done?" It's a biochemical disorder. It is not a disorder of mothers who are not competent mothers. And it is fascinating to read in the leading psychiatry journals from that time. You would get these editorials from grand old men in the field where they would be saying, "I have spent my whole life researching this disease. I have spent my life trying to fight this disease, which is hell, which tragically destroys lives. I've been trying to do the right thing. I have been trying to help people. Look what I've done instead." This realization that ran through the community that parenting style has nothing to do with it, and it's half a century's worth of mothers bringing in their late adolescent for the first diagnosis and being told, unfortunately, it's this nightmare of a disease. How could this have happened? Where does it come from? You caused it. You caused it with your mothering style. Endlessly during the period where modern biochemistry sweeps into psychiatry, over and over there are cases like this where the whole field has to stop and say, "My God, what have we done?" Telling people they caused it through some parenting style, something of that sort. It's a biochemical disorder. So this was a shocking finding at the time and transformed the field in terms of schizophrenogenic mothering going down the sink at that point. Nonetheless, there is an interesting literature showing abnormalities or oddities in the way communication works in the families of schizophrenics. And this is a field now that's called communication deviance. What you see is, on the average, among first-order relatives of schizophrenics, parents, siblings, immediate family, what you see is, on the average, an odd communicative style. You see a very fragmented sort of communicating, a very telescoped, sort of terse, broken phrase sort of style. This has been noted very often. Again, this is not what is seen in every close relative of schizophrenic, but higher than an expected rate. What you also see is all sorts of realms of, in a sense, private communication between schizophrenics and their close families. And the way this is shown is with things like, this was a classic version, you take schizophrenics and you show them like a bunch of, no, that's not what you do. You give them a Rorschach print, one of those ink symmetrical things that's just completely chaotic looking, and they look at it for a while, and then you put it into a stack of a dozen other ones, and you mix them up, and you give them to the parents of the individual, and the schizophrenic or the healthy control is now trying to describe to the parents which one they saw, how to find the correct one in there. Control healthy individuals sitting there trying to explain which Rorschach blot they saw, like no accuracy whatsoever. The schizophrenic starts saying, it looks like a butterfly with a Van Dyke beard and ears on fire, and the parents pull out the right one instantly. It works in the opposite direction as well, where the parents are the ones trying to describe the Rorschach test. It only works within families. The parents of a schizophrenic are no better than at chance when doing it with someone else's child of a schizophrenic. There seems to be this going on. Logical interpretation. This has nothing to do with the emergence of schizophrenia. This is an obvious compensation. You have a child, you have a sibling who is this thought disordered, and there's going to be a whole lot more adventurous communication in the family to try to compensate for it. Few other things in terms of early experience, and this is a whole other domain of the disease, which is being exposed to all sorts of infectious thingies. And this is a really interesting, provocative literature floating around. There's a far higher than expected chance rate of schizophrenics whose mothers were exposed to a number of different viruses in third trimester of pregnancy. Some sort of perinatal stressor, pathogenic challenge to the system. When you look at the genomes of schizophrenics, they have a much higher than expected rate of viral DNA that has been inserted in there, things called retroviruses. The technical matters don't matter. The main thing is more evidence of higher exposure to viral pathogens. An elevated history of neonatal viral infections. And then the coolest one of all, which has to do with a protozoan parasite, not a virus or a bacteria, but this protozoa called Toxoplasma gondii. And not Gandhi in the Gandhian sense, but probably because it's even pronounced differently. Okay, how are you pronouncing it these days? Gandhi, because there's two I's at the end, which the old Mahatma never quite came up with, but this parasite manages to get more I's in there than he did, so it's Toxoplasma gondii, as everybody knows. Toxoplasma is interesting. It has this interesting life cycle. It reproduces in the gut of cats. It comes out in cat feces. Feces are eaten by rodents. Now in rodents, and Toxo's evolutionary challenge has been to figure out how to get rodents inside cat stomachs. And Toxo does this amazing thing, which my lab is doing some work on, including Patrick, and looking at the thing that Toxo does is it makes rats begin to like the smell of cats and to go up and check it out, and soon you are inside the stomach of the cat and completing Toxo's life cycle. How it does it is incredibly interesting and slowly emerging. So what's going on with Toxo in humans? People who are infected with Toxo have a higher than expected rate of mild neuropsychological disinhibition, a little bit of problems with frontal regulation of behavior, higher than expected rates of serious car accidents, higher than expected rates for the same degree of depression, of attempting suicide, a picture of a certain degree of impulsivity. Not big effects, but nonetheless it pops up there. But parallel with that, from day one, there's also been a literature showing that toxoplasma exposure increases the risk of schizophrenia. individuals whose mothers were exposed to toxo during pregnancy, or looking at schizophrenics and looking in their blood and seeing higher than anticipated levels of antibodies against toxoplasma, evidence of this whole world of a connection between cats and schizophrenia, and all sorts of hints there. Very, very slowly emerging field. It is a real finding, and it is a well-replicated one. There's some connection there. So where does these genes having to do with immune function come in? Maybe this is pertinent to this world of viral correlates of schizophrenia, parasitic ones. Nobody knows. Finally, what have we got? This challenge that we're going to have with, when you read the depression chapter, all of that, is how do you put these pieces together? How do you put together adolescent stress with prenatal viruses, with enlarged ventricles, with funny genetic abnormalities here? There isn't a very good integrated model at this point to how to put the pieces together. The field has not gotten that far. So we're talking about genetic abnormalities, blah, blah, all of that, and thus you know our final box has to be the evolution of schizophrenia. Where did schizophrenia evolve from? First sort of question you would ask is, well, do you see something like schizophrenia in other species? And you don't. You look at complex primates and you see things that look like depression. You see reactive depression. You see melancholia. You see in some cases depression so severe as to prove fatal. You don't see animals having loose associations with proverbs and concrete thought and delusions and hallucinations. Animals that start acting schizophrenic get eaten that evening. So there's not a whole lot of insight from the zoological world. There's not any animal precedents for schizophrenia. Okay, so how about in humans? How did schizophrenia evolve? We are now back to one of our first lectures. Why do giraffes have long necks? Because it's a good thing that allows them to pass on more copies of their genes, because it's an adaptive trait. By the rules of Darwin, schizophrenia is maladaptive. Schizophrenics have a lower reproductive rate than their unaffected siblings. By the math, that is thus a trait that should be being selected against. Yet, schizophrenia persists at this 1 to 2% in every culture out there. Historical records indicate things that convincingly sound like schizophrenia have been there forever, and thus one has to bring up a question that always lurks in a scenario like this, which is, are there circumstances where schizophrenia is in fact adaptive, where it is advantageous, where it increases one's reproductive success? The only domain where that has had any evidence at all in the literature is schizophrenics appear to have a lower incidence of certain types of cancers, in particular lung and throat, esophageal cancers, and that's after controlling for smoking rates, all of that. Not a big effect, but that causes people to mumble something about maybe schizophrenia was selected for its anti-cancer properties and the disease and balance selection, all of that. However, there is another possible adaptive thing that's lurking around in there. Something which causes some of these traits to not only no longer be maladaptive, but to be wildly useful in certain contexts of human society. And what you'll see is it's not full-blown schizophrenia, it's the milder versions that you see in some of the relatives, and thus, just to give you a sense of where things are heading, we'll talk about that on Friday in the lecture on.
For more, please visit us at stanford.edu.